Hello guys, in today's video, we're going to make a program that can convert number system from decimal to binary. We are going to convert decimal value of 5. Its binary is 1, 0, and 1. The process of converting decimal to binary, we use bits of binary numbers. We have 1, 2, 4, 8, 16, 32, and so on. We are going to exclude bits of binary numbers that exceeds to our decimal value. Since our decimal value is 5, then below its value are only included. So in converting, we're going to make a condition if our bits of binary numbers is below to our decimal value. So more like, we're going to check if our 4 is less than to decimal value of 5. Since it is true, we can print 1 bits value. So after that, we are going to add these two value here. So 4 plus 2 is equals to 6. After adding these two value, we then check the condition if the sum is less than to our decimal value. Since 6 is not less than to 5, it is false and we're going to print 0. After that, we're not using the sum of these two values because it is not below to our decimal value. What we're going to do is we're going to add 4 to the next bits of binary numbers. So 4 plus 1 is equals to 5. Since 5 is equal to decimal value of 5, it is true, then we print value of 1. So that's how we convert the decimal value of 5 into binary. Next is we're going to convert decimal 7 to binary. So same process, we're going to check the condition if this 4 is less than to 7. Since 4 is less than to 7, it is true, then we print 1. And again, we're going to add these two value. So 4 plus 2 is equals to 6. Since the sum of these two value is less than to our decimal, then it is true and we print 1. Since the sum of these two is less than to our decimal value, we can use the sum of these two value. After that, we're going to add the value of 6 to the next bits of binary number. So 6 plus 1 is equals to 7. Since 7 is equals to 7, it is true, then we can print 1. We convert the decimal number of 7 to the binary value. And we got 1, 1, and 1. Now, if we apply this concept into creating our program, we encounter one problem. This is how can we determine the exact position of our decimal in bits of binary numbers. If the user input decimal value of 7, how can we determine its specific position in bits of binary numbers? Because if we fail to get the position, in this case, if 7 value goes to the 8 bits of binary numbers, then we get an error and unable to print binary values. Our solution is to make use of data structure. The type of data structure that we use is an array. In constructing our program, we declare an array variable. Inside of this array data is our bits of binary numbers. For example, we have 4 elements. We can access these elements through index. 1 is our index 0, 2 is index 1, 4 is index 2, and 8 is index 3. Now, we declare two variables, count1 and count0, and set its value by 1 and 0. If we have decimal 7, we have to make sure that our decimal sets to index 2. By doing that, we have to make use if statement. Here we have two conditions. If our decimal is less than to 8 and if our decimal is greater than 3, Then proceed to this statement. In this case, our decimal is equals to 7, so 7 is less than to 8 and 7 is greater than to 3. Our decimal value satisfies to this condition and we set index value by 2. After that, we print the value of 1. We still have remaining bits value. By getting that, we have to make a loop statement. Here we initialize our I value by index minus 1. It then checks the condition if our I is greater than or equal to 0. After the loop, we decrease our I value by 1. Here we have variable sum to calculate the elements of index 2 and index 1. Whatever the value, it will store to some variable. It then checks the condition if sum is less than or equal to decimal. If true, it will proceed to this statement. Or if it's false, then it will proceed to else statement. We have to make a quick simulation for this statement. In our loop, we initialize I by index minus 1. It then checks the condition if our I is greater than or equal to 0. Then we have to add the elements in index 2 and index I. Our index is equals to 2 and the element inside this index has a value of 4. And our I is equals to 1 and the element inside this index has a value of 2. After adding these two elements, we have to check the condition if our sum is less than or equal to our decimal. Since 6 is less than to 7, we are going to print 1. After printing, we are going to assign the sum value in our index 2. And then, it loops again. Since we decrease our I value by 1, our I now is equals to 0. It then checks the condition whether our I is greater than or equal to 0. Because it is true, now we have to add the elements in index 2 and index I. Our index 2 is equals to 6 and our I is equals to 0. Therefore, we are going to add these two elements. So 6 plus 1 is equals to 7. We then check the condition if this 7 is equals to our decimal. Since it is true, we are going to print 1. And we are going to assign the value of this sum to our index 2. And then we decrement our I by 1. Since our I is equal to 0, then we subtract it by 1. So it will become negative 1. As we know, negative value is not greater than to 0. And then it will not loop again. Now we successfully converted decimal 7 into binary. And this time I will create the program.
Yeah, boy.
Now, we can convert any decimal number into binary. Please like and subscribe for more videos.